Alright, in this video, we're going to take a look at writing the equations when you're given a system. So you're going to have two equations, and we're going to have to identify the solution as we're doing this. So what we're going to look at is we're going to make sure we write our equations in slope-intercept form. So that's why we spent so much time in the beginning of the semester working on identifying slope and y-intercept and then writing equations. So remember, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So if we look at our graphs, we have two equations and two lines. And then we also have where they're intersecting. So when you're writing a system, you want to draw the bracket to show that you have the system, and you want to identify the two equations, and we want it in slope-intercept form. So when we look at the green line that I highlighted, you want to first find the y-intercepts. Remember, the y-intercept is the point on the y-axis. So I'm going to put a dot on the y-intercept there. And I'll label it. To figure out the slope, remember, you're just counting from point to point. And on this graph, the other points are already plotted as the intersection point. So I'm just counting up to, and then over 1, 2, 3. So my equation for the green line is y equals 2/3 x plus 2. For the blue line, you do the same thing. You find the y-intercept. You look for another point in the line, and it looks like the only other point is actually where they're intersecting, and you count. So for this one, it looks like we're going up 8 over 3. So my equation is y equals 8/3 x plus, and actually this one is minus, because my y-intercept is negative, minus 4. So there's the two equations of my lines in that system. The solution then is where they're intersecting, and that's going to be at the x value 3, y value 4, so 3 comma 4. So we'll follow the same steps for each line. You want to identify the y-intercept, figure out the slope, and then write it in slope-intercept form. So for the yellow line that I highlighted, the y-intercept's at -2. Another point in that line looks like it's just right there, and then where they're intersecting. So my system of equations here would be y equals, for the yellow line I'm going down 1 and then over 1, 2. So it's -1/2 x, and my y-intercept's at -2. For the blue line, the y-intercept's at 2. Looking at another point on the line, it looks like it's right there. So I'm going down 1, 2, 3 over 1, 2. So y equals -3 over 2x plus 2. The solution is where they're intersecting. So the solution there is going to be 4 comma -4. Same process for the next one. We want to find the y-intercept, then find the slope, Alright, so in this problem, if I look at the yellow line, the y-intercept is up here, and then it looks like this slope is up 1 over 1 for each point. So for my first equation, it's just y equals 1, because 1 over 1 is 1, 1x plus 4. For the green line, my y-intercept's down here at -1, and I'm going down 1, 2, 3 over 1, 2. It looks like I'm going down 3 over 2. So that means negative 3 over 2x. And the y-intercept there is at negative 1. The solution is where they're crossing. So I have to count now. I'm at negative 2 up 2. So my solution is negative 2, comma 2. A couple more examples that we'll take a look at, and then you can try the practice problems. So remember your steps. Identify the y-intercept, identify the slope, write the equations, and then find that point of intersection. So in this graph, if I look at the blue line, the y-intercept's right there at 2, and then it looks like the slope here is up 1 over 1, up 1 over 1. So I have y equals x plus 2. Remember, you can write it 1x is just x. For the green line, my slope is at, or my y-intercept is at 4, and here it looks like I'm just going down 1 over 1. So y equals negative x plus 4. The solution is where they're intersecting, so I'm at 1 comma 3. For letter E, there is no solution because they're not intersecting. And so these lines are parallel. What we're going to notice about these lines is something unique to parallel lines. The y-intercept's already labeled, and I've got some points labeled. So for each equation, I'm just looking at identifying the y-intercept and the slope. So my y-intercept for the green line is at negative 2, and then my slope is up 2 over 1, 2, 3, 4. So I can actually simplify that to up 1 over 2x plus negative 2, or just minus 2. Because again, I'm going up 1 over 1, 2 for the slope, and then the y-intercept's at negative 2. For the yellow line, the y-intercept's at 1, and I'm also only going up 1 over 2. So my slope is 1/2 x plus 1. And this is no solution. So for parallel lines, what you'll see is that the slopes are the same. So that means the lines are parallel, and then the y-intercepts are different. And they will not have an intersection point. For the last one, I only see one line. So when I'm seeing that, generally what that means is that the lines are on top of each other, so it's hard to see the graph of the lines on top of each other. But you're going to write the equation. It's going to be the same equation twice. The y-intercept is at 4, and the slope is up 1, 2, 3, 4 over 1. So the slope is 4x plus 4 for the y-intercept. And the solution here is infinite. So remember, when you have the same line, every point on that line exists in both equations, so you have infinite solutions. So you're going to work on writing the equations of lines given the graph. So remember, you want to find the slope and the y-intercept and put that into slope-intercept form.